Okay. Okay, it looks like most people have answered. Okay, so it looks like most of you guys on the first question are currently in AWS, which is great. And most of you are currently using HashiCorp tools. I do see some of you are exploring those options. Okay, cool. All right, I just muted whoever that was. Okay, and then some of you guys are currently using HashiCorp tools for the majority, and then there's a few of you guys exploring. And then on the question of who is hands-on with HashiCorp tools and who is leadership, it looks like majority of you guys here are hands-on. We've got a few leadership, and then a bit of you guys are a little bit of both. So that's great to know for today's session. Okay, cool. So now, thank you for your responses. I am going to go ahead and welcome Welly from AWS to take over and start us off with our first presentation. So welcome, Welly.
Thanks, Marissa. And thanks again for doing the poll. I think that's very useful for me as well to understand who is in the audience. Hi again, everybody. My name is Welly Siauw. I'm a partner solution architect here at AWS. This will be my 4th year in AWS. And today I will kind of guide you through a couple of quick recaps about what we discussed in the past events. And then the primary thing in here I would like to discuss is about the secret management in AWS and why you should care about that, and how partner products such as HashiCorp can help in here as well. So again, my name is Welly. This is going to be a very quick recap, probably about 10-15 minutes in here. We're not going to get you bored with presentation. Today is all about immersion day. Today is all about you getting a hands-on. From the audience, I can see a lot of hands-on team members in here as well. Then don't worry, even if you are not hands-on, there's a lot of knowledge you can gain just by kind of looking at the lab itself and going through the presentations. So before we go, because I see there's a lot of people with hands-on, so I think it's good to kind of get a quick time for a quiz. There's going to be only 3 questions. I hope you all can answer that by just putting your comments in the chat. And then again, this is only for fun. There's no scoring, anything like that. Okay, let's get started. So it's only a true or false, so very easy. First question, I can only use static or long-lived access key and secret key in AWS. Select true or false. All right, give another 10 seconds for anyone to answer. Wow, a lot of quick answers from the audience. That's great. All right, let's take a look. What's the answer for that? Yes, that's false. You can use STS or security token services that's enabled you to request temporary access credentials. In fact, today you're going to learn about how to do this using the tools such as a Vault. All right, next one. This is a little bit tricky. Root account has all the power and nothing can prevent it from taking actions. Look here, there's a small hint, AWS organizations and service control policy. Again, true and false. Wow, I can see there's a lot of hands-on audience in here. Pretty quick to trigger the answers. Give it another 5 seconds for everybody. All right, and the answer, yes, that's right, it's false. While it's true that root account has all of the power, but if you're using service control policy, you can restrict permissions for IAM users and roles in the member accounts, and that's including the root account itself. It's very powerful, and it's a good way and a lot of good reason why you want to use AWS organizations and also service control policy. All right, the last one. I know there's a lot of people in here is also a fan and also hands-on experience with the HashiCorp tools. So this question is for you. Question is, HashiCorp Vault generate AWS access key credential dynamically. Is that true or false? All right, I see some answer coming in. I'll give another 5 seconds and then we can check what's the answers. Wow, I can say like everybody in here is really hands-on and really have a good knowledge. I don't see any false answers so far. So that's true. You can use HashiCorp Vault. You can generate access key dynamically. And in fact, you're going to do this later on in the lab. So great job, everybody. And thanks for going through the quick quiz in here. It's good to get relaxed. And now we're going to go ahead with quick recaps. So for you, a lot of you already know this. So I'm not going to do too much of talkings about secret management in AWS. But there's a couple ideas that I think is important for us to recap again as we're going through the lab today. So first of all, it's like, why should I care about doing secret management? And why is that important? Now, if you look at how I used to do security before AWS, I'm coming from on-premise applications and IT management, etc. And this is how I typically do security before AWS. I have this like a trusted, untrusted zone, castle, essentially, your fort. Then you have firewall, you have IDS, you have maybe identity protections, you have physical security protections, everything that you have for like a perimeter access protections. And then you have this idea of trusted and untrusted zones. And you typically look at people from identity based on things like IP address, port, MAC address, and etc. And this is typically what's the ideal looks like if you are thinking about doing security before the area of the cloud. Now there's a couple of challenges with this model. And these challenges is not because the tool is not good, but it's about the variations of the tools that you have to use, the vendor and the technology. And because of all of this interconnected that you have to do, typically you have a two challenge, which is a lack of visibility, because you have so many tools, so many types of logs, so many types of endpoints and API that you have to use to look for any visibility. And the second part of that is kind of like amplification of it as well, is that because there are so many types of tools and so many types of API and things that you have to use, you have this low degree of automations. And the challenge is when you have these two particular issues, right? Lack of visibility and also the lack of automations. How does that impact the secret management? If you look at it, there's a couple of things. First, now you're gonna have these complex solutions in terms of secret rotations. And secret rotation become long overdue because again, you have so many endpoints you have to take care of, many different types of API and interfaces, and it's become harder for you to manage it. And the second thing is that you have these unreliable rotations because again, you have so many types of endpoint and services, applications and vendor systems and etc. When you have to try to do some automation to do the rotations, the API might have changed and etc. And that's really causing a problem because you might have an outages because secret is not rotated properly. Secret was rotated, but then the application did not receive the new secrets and etc. And the other part is that you don't have a clear audit because there's so many systems, secret is everywhere. And at the end of the day, you start thinking about, well, I want to make sure everybody in my team have access to this in case like there's an outage and etc. So you coming up with this idea is like, I build a group, the group have access to the secrets. I used to have those, like I used to manage a team of 70 and I have access to every secret in the organizations, whether I know what is going to be used for or not. So there's really no clear audits and too many human access. And it's a good intention, but it's not a good mechanism. So we understand like we should care about secret management. So now quickly, if you look at why and how should I care about secret management in AWS, there's a couple things in here. I want to focus on the identity and access management for today. But this is the pillars. If you look at how you want to run security in AWS, ensure you have good identity and access management. We talked about STS a little bit earlier. You want to have data control, looking at the audit logs and etc., and ensure you have a way to track back who is doing what, such as using AWS CloudTrail. Infrastructure protections. You want to look at what has been done by AWS and how much additional things you have to do. A lot of this has been provided by AWS in terms like DDoS protections and some of the firewall mechanism as well. Same thing with data protections as well. You can look at how you want to do encryptions using built-in encryptions within the services, or also including like an additional key management system that you want to handle. Then you look at incident response, how you can automate the whole incident response as well. Now you have detective controls, you have the protections, how you can use the existing API within AWS to do all of that, maybe using CloudWatch, Event Bridge, Security Hub, etc. And lastly is about the compliance. A lot of the services within AWS already have those compliance built into it, which can help you to gain your compliance requirements. Of course, you have to kind of look at, again, what is your security control that you have versus what you can delegate to AWS. Now, looking at that, it's coming back to whole shared security responsibility models in what we call we protecting security of the cloud. This is about the infrastructure, this is about the services that you use, and then depends on the type of services that you use, you might have more responsibility or less responsibility. You can imagine if you're running an EC2, for example, then you are responsible for OS patching and stuff like that. But if you're running your container in Fargate, for example, or you're running your code in Lambda functions, then your responsibilities shrink because AWS then handle those infrastructure patchings and security and etc. And then you care more about your data, essentially. Talking about data, then it's talking about secrets, right? So a couple key takeaway in here when we look at secrets management. First, it has to be about zero trust. You cannot just because someone can pass through the firewall, then you trust them. You have to identify them for every single point within the data that they're trying to access, right? Identity and access management, such as using IAM, helps you to do that. The other key takeaway is about just in time. So you should only grant people access to the secret when they need it, not just because, for example, I have access to all secrets, even though I'm not sure what I'm going to need it for. The other part, there should be no human interactions. When you can let machine-to-machine talk, and there should not be any human interactions needed, for example, to update the secrets or to put the secrets in particular locations. Which also means then automate everything where you can get the system to automate itself. Like having a single tool that can do all of that, of course, will be a plus. And when you can automate everything, so you don't have human interactions, it means like your rotation frequency will be increases, right? Even better, you can just do it just in time, as I mentioned. And audit is still a key takeaway because you want to make sure like you know who is doing what secret that they're using, and then how that's gonna impact, for example, if you're doing some chain investigation about any security breach. And as much as we talk about securing the access, integrity is also important, like how you ensure those secrets are still valid, like how you protect the secrets in terms of encryptions and other mechanisms. And lastly is all about availability as well. It doesn't matter how good your system, if you have a secret management that is not available when you need it, then that's also a problem with the security. So this is a key takeaway. I mentioned earlier about shared responsibility model. I think today is a good demonstrations of that, because the more you look at the types of your journey in AWS in terms like your migration of workloads, the type of services that you use from EC2 to Lambda and etc., your responsibilities shrink. Then you have more focus, for example, on looking at this secret management in here. And I want to carry this back to Mike, where he talked about how partner products such as HashiCorp Vault can help you to focus more on the secret management as part as well. So with that, thank you again for staying with me for this quick overview. Mike, I hand it back to you now to talk more about Vault.
Thank you, Willie. Appreciate that. And let's go ahead. And like what I said, and I know that based on the poll, quite a few folks are familiar with HashiCorp products. So I won't spend a lot of time here. Just want to kind of give a brief overview of the cloud operating model. So like I said, at HashiCorp, we have quite a few different tools. Most folks are familiar with at least one of them. And really the point here is that we want to lead that cloud infrastructure automation space, right? Making things very easy to be able to automate, and ultimately giving us a consistent workflow so that we can, no matter whether we're on-prem or we're in AWS, we're able to do things like provisioning or securing or running. So let's kind of talk about how we got here, right? And that transition that we've seen. So probably most of us are going to be familiar with what we consider a traditional data center, right? That 4 walls and a pipe where we're using dedicated infrastructure and it's very static, right? We're using static IPs. We've got a clearly defined perimeter. But over the last 20 years, we've seen a pretty large shift. And really what's driving this shift is applications, right? Our applications have changed over those years. So when we start to look at a more modern data center, a dynamic data center to support our applications, we see things like private cloud and public cloud being used together. So things like private cloud to host our system of record. Maybe we have a really large database that we're going to use as a system of record, but our applications require a much more dynamic approach, right? Things like mobile applications, ML, AI type workloads require us to be able to scale up and scale down much more dynamically, as well as with AWS, all the features and benefits that make this very, very easy. And we want to be able to utilize all of those things. So through each individual layer, and we will be focusing on Vault today, which is the secure layer, but we see these challenges at every single layer, right? Whether it's dedicated servers or high trust IP-based type controls, static IPs and host-based controls. But when we start to look at that more dynamic side, we see that shift happening immediately, right? Capacity on demand, low trust. We don't necessarily have full control of our perimeter any longer. So we have to use things like identity to be able to secure things. Being able to refer to things as services, not necessarily IPs, makes a big difference. And obviously having this fleet of servers to be able to deploy our applications becomes a vital part. Now, what I've seen throughout the industry is as we start to do this, if we don't have a unified tool set, what we end up with is this siloed approach. We have this idea of each one of these individual areas kind of being done differently than we did on-prem in our private cloud or in our dedicated infrastructure. So with this inconsistency, we have these silos of workflows as well as silos of knowledge. So it makes it hard for us to have confidence to go from things like maybe production is living in our private cloud and AWS, but maybe our development environments are living on-prem. This inconsistency makes it hard for us to be able to control what's going on. And this kind of bears itself out in really long application delivery times. And usually what this is a flurry of tickets between teams, right? We're sending a lot of different tickets back and forth because we really don't have the empowering type of capabilities of a consistent workflow. So we're asking each team, because of these silos, to be able to maybe complete some task force, and this takes a long time. But with HashiCorp tools, we look at this really differently. Through each individual layer, whether you're talking about provisioning, securing, connecting, or running, we provide a consistent workflow for all of these items, right? Terraform for provisioning, Vault for securing, Consul for connecting, and Nomad for running. So providing that consistent workflow really has a dramatic impact on how we look at things in our deployment cycles. It also has a really dramatic impact on the amount of time it takes because of these consistent workflows. If we know and we are confident that we can deploy, whether it's in dev, QA, UAT, production, and we have a consistent workflow, this really does kind of knock that time down from 22 weeks to more like a 5-minute type single stage application delivery. And this really is how we look at things at HashiCorp. This is the HashiCorp Cloud Operating Model with the HashiCorp Suite. Each one of the individual layers, the 4 layers that we look at, the main 4 layers of infrastructure, really help us achieve that, right? Terraform for provisioning, Vault for securing, Consul for connecting, and Nomad for running. So with that, I would like to turn everything over to David, and we will start with the workshop.
Okay, perfect. Thanks, Mike. Appreciate it. I'm going to go ahead and share then. Give me 1 second. All right. And in the meantime, my name is David Howes. I'm one of the senior solutions engineers from the Northeast, specifically just outside of Boston. I'm in Sherburne, Mass. So if anyone's from there, go ahead and speak up in the chat, but I highly doubt it. It's a bit of a smaller town. So we're going to be going through the Vault workshop here. We're going to have quite a few things that we get to today. So let me open up the table of contents. So we've got 8 sections in total. There are labs built in there. We're going to start with overviews of Vault, as well as diving into some of the components, which are a bit more important, things like the secrets engines, the authentication methods. We'll get you hands-on with those so that you can actually see what they're like. And then we'll get into some more AWS specific topics as well, which I think will be really cool to see. One thing I will mention here is just, I know we said it before, but if you could rename yourself just to help out Marissa, I think it's worth reminding, especially if anyone joined in late, just to put your company name after your regular name. It'll really help us out when we go to make those labs. In terms of the lab platform we're going to be using, I'm going to cover this right before we jump into it as well, but I think it's worth stating now. So we use Instruct. It's a really cool platform. It spins up a couple environments, gets you access to an AWS environment, a command line, but puts it all in one browser window. It's split up into really 3 tracks, which we're going to go through in this exact order. And one thing I will say is, when we get into that, try and get off of VPN, try and make sure you're using something like Chrome. It's all built around that, or at least something that's built on Chromium. And I have seen some people sometimes inside of a VM that causes some odd behavior as well. So if there's anything you need to get set up in the meantime for that, I recommend you take a look at it now, but you'll still have quite a while before we actually get into those labs. So without further ado here, we will jump into our chapter 1. So this is our HashiCorp Vault overview, really how we can help you solve all your common use cases, what the really problem statement is around Vault. And I think we've heard some of that already from Welly and Mike. They've done a good job covering it. So I'm not going to beat it to death here, but we'll take a look. And if there's anything you have questions about as we go through, feel free to drop them in the chat. I'm not necessarily going to dive into them myself, but we've got some great TAs in here who will be more than happy to answer some of your questions so that we can keep moving along, but we can make sure we get you your answers as well. So first thing here is really, what is Vault? And I think we've touched on this a little bit already, but it's a way of doing platform agnostic secrets. We'll get into what a secret is because I think it's a lot broader than some people actually think. Everything's API driven, which is really important when it comes to something that is really developed for machine authentication and authorization. And in this way, it lets us safely store all of our secrets. And because of that agnostic approach, we'll help you get something like a hybrid cloud environment if you're using AWS today, but you also still have some on-premise resources that you need to leverage, and creating a consistent experience across that. And I think, like Welly mentioned on his key takeaways, dynamic credentials, short-lived credentials, just-in-time credentials, incredibly important for this new day and age, especially as things have gotten a lot more distributed. And we also have other functionalities within Vault for handling things like certificates or encrypting any sort of data you want to throw at it, sort of an encryption as a service. But like I said, we'll get more into exactly what a secret is. But before we dive deep into Vault, it's important to understand, once again, what is that problem statement? Why have we even gotten to this point where suddenly we need a secrets management platform? And I think Welly even described it himself as, this is a castle and moat situation. Forever, we operated in this traditional security model where we had main data centers. We'd put a big firewall in front of them. We'd be able to say, hey, we're stopping anything malicious coming in. Once you're within these walls, we can reasonably trust the resources we have out there. So we can filter based on things like our IP address. Generally, the way applications were being made for a long time as well is a bit more monolithic. They didn't change too much, which meant those different IP addresses that we had were also long-lived. Once those were provisioned, they generally stay there for a long time. And if we had to have any credentials connecting these different aspects, we could bake them right into the source code, or we could have these static configuration files. And, we were still probably doing some rotation. I've run into customers myself who they have processes where you have to submit a ticket. It takes quite a few weeks, but they're tasked with doing it for their apps about once a year to remain compliant. But obviously, with a very changing world, right? We've run into problems, and that comes both from our application development changing, having applications which are now being broken into smaller and smaller pieces. They're moving around to different locations a lot more. They're scaling up and down quickly. It's increasingly difficult. The complexity has really gone off the charts in terms of how do I keep track of all my resources, who they are, what they're supposed to be able to access. The IP address-based rules just don't fit anymore. And a lot of that power has come from platforms like AWS, which allow us to scale so quickly and on demand that they've brought out issues that we've never had to deal with before. And we're especially working, you might be across multiple AWS regions, as well as trying to connect to on-premise. We're a lot more spread out than we used to be, which makes connecting all of these a lot more difficult. We suddenly need to authorize and authenticate so many more different services, which all have their own ways of connecting and all have their own credentials associated with them. So some things you may have done to cope might be, you have shared service accounts, which you use on broad use cases because it's just impossible to get that exact service count for each individual thing. Like I talked about with some of the customers I've seen, you might have difficulty rotating those because it might be a UI-driven process at this point where you need to submit a ticket, you need to go into some system to request new credentials, and then decommissioning those and determining who has access, especially if someone leaves a company, can be really challenging. You just never know who's seen a certain secret, who decided to take those credentials they saw on the back of a keyboard and decide to use them in their app to access that same database. It becomes very hard to track. And so revoking any of those can become quite difficult when you don't know exactly what's out there. So we have this new world, which we think looks a bit more like this. We have a very distributed approach, right? These are yurts in this case, right? We're talking about a much more, we would almost relate it to a nomadic approach, right? You never know quite where your apps might be, how they're going to have to be protected. Are they running on-premise, in the cloud? Even when we're talking about AWS, are you running on US East 1 or are we running on US West 1? And are we actually moving that application or is it distributed across those? So we do gain lots of advantages, as you've probably seen though, especially when we start to leverage platforms like AWS in terms of how fast we can approach development, and security has just been needing the tools to go alongside that. So that's really what brings us to Vault at the end of the day, this idea of our identity-based security. And so this is an overview of Vault in general, right? It really has three key aspects, and it all starts at the top here. So we have different clients, and these could be humans or machines. With humans, I mean, client is very easy to figure out what it might be, right? We don't have too much variance there, but as we get into machines, well, we could get a lot broader. An EC2 instance on AWS might need access, or you could have a different approach with more modern versions of computing. Maybe you're using some sort of managed Kubernetes offering from AWS, or you're even leveraging something like serverless Lambda. Those are powerful features, and they also need to be verified, and they have slightly different ways that they operate. You could even have things like CI/CD pipelines, which need access. So client gets a lot broader as we get towards machines than it does with humans. And so once we have those clients, at some point, they're going to have to connect to something. But before they can do that, we need to validate who they are. We've already talked about it's a lot harder to judge things by IP address. So we have this distinct need to have an identity associated with them. So that's where our authentication methods come into play. And for humans, this might be, your single sign-on programs, Okta, Ping, whatever it might be. You might have something that's LDAP based. You could even have simple user passwords, but on the machine side, we could go a lot broader. So you could have something that is based off of Kubernetes for its verification, or authentication. You could have AWS IAM methods, which use your which prove your authentication. So prove that, hey, this EC2 instance is who it actually says it is. And then once we've authenticated, we kind of move across, and there is a, I know I said there were 3 points to this, but there are those policies that go along with the authentication methods as well, in terms of, okay, we know who you are now, or what you are, what you actually have access to. So we can take these policies and apply them across those identities. And from that, then you get into your secrets engines, which are really, what are we authorizing somebody to actually access? And in this case, one of the simplest ways is something like a key value store. You might have, at first you might just bring in the secrets that are within your organization. So you might have, hey, I have static database credentials out there. I want to throw those into a key value store, have people access them. But as you get more complex and as you start to adopt Vault more, you might move into those, okay, I want dynamic database credentials instead. So I want to generate them just in time, and that can be a different secret. Or maybe you have PKI data. We have certificates we need to manage. You might even have, SSH keys. We can broaden the idea of a secret to even be related to encryption as a service, right? You might just have a piece of plain text, which really should be a secret. You don't know if you can rely on, the backend storage to be encrypted, or you don't know if you can rely on, the database application, whatever you're writing to actually be encrypted. So in this way, we can send that piece of plain text over to Vault to be encrypted. Sorry, a little cough. And have that returned to you so that you can store it anywhere you want, and you don't have to worry about an underlying system to handle the encryption, but rather we can handle it on the app side instead. So this is the general overview, and we'll jump into a bit more of the architecture as well. But really, it comes down to that idea of identity, right? And I think we've kind of hit this over and over, so I'm not going to stand on this slide for very long. But we're trying to use identity-based rules, right? We want dynamic, short-lived secrets wherever possible. I think we can generally assume in this day and age that it's not when a credential is potentially going to be leaked, or it's not an if it's going to be leaked, but rather a when it's going to be leaked. And it could be no fault of anyone's, right? It's an application log that puts it out. It's a log from your monitoring tool, right? You're not sure where that could come from, but at some point you can probably assume that a credential will be leaked, especially with how many we have to deal with these days. And of course, we want to be able to track all of that and easily validate any entities that we have out in the environment. So moving along here, we then have our secrets engine. This is the first screenshot I think we're showing of it. Some of you may already be familiar with it. Maybe for some of you, this is your first time seeing it. You can see all the different secrets engines that we had mentioned before: KB, PKI, SSH, right? Transit to your encryption as a service. I didn't mention like time-based one-time passwords, but we support that as well. You can of course see your AWS in there for either, I believe it's access keys in this case, and we can create dynamic access keys to connect to the cloud, which I think is a huge boon for security teams out there. And of course, we have some infrastructure components as well, databases and some of the other Hashi products that Mike had mentioned. I will say, just because you don't see a secret engine here doesn't mean that it doesn't exist. In some cases, it might be a supported feature of Vault, but it might just not be supported, or rather not shown in the UI. It is a system that's really created for machine authentication and authorization first and foremost. So you don't necessarily need a UI for a lot of components. And we also have the ability for you, if you want, to go out and create your own custom engines. And you'll find this if you have something that you think isn't supported for Vault, go ahead and look for it. You never know, if you might actually find somebody's already creating it, created it, posted it open source, and you can leverage it yourself. So it's really an extensible system. It's incredible to see how many different secrets that you can handle with it, and how broad of a term that actually starts to become. But want to take you through a deeper architecture as well to understand how deep this is, what all the individual components are, and how they work together to create the system. And I'm sure for anybody who's been using Vault for a little while, this will be really interesting. The architecture is not necessarily something you have to know in depth to use Vault, but I think it helps us to understand it a little bit better. So what you'll see is kind of 3 segments here. We have the front end, which handles our API. We have this core, which is behind, as you see on the left, a barrier. We'll explain kind of what we mean by that in a minute. And then on the bottom, we have the storage backend, right, where we actually store everything. And of course, we're not going to necessarily trust that backend, right? We want to encrypt it. And that's part of where this barrier comes in. So that barrier is almost what we call a seal on the cluster. So whenever you initially start Vault, as long as it's not a dev server, it's an actual production server, you're going to have it start in a sealed state. So what that means is that we've encrypted the storage on the back end with an encryption key. That's been stored with the back end. We have a root key as well, which then helps us to encrypt that storage encryption key. And whenever we start up Vault anew and we need to unseal it, we need to rebuild that root key. And the way we do that is with a process called sharding. So when you first create Vault, you're going to receive, essentially, you can change the number of keys, but generally 5 key shards, and you're going to distribute those to different individuals who are all going to have the keys, and you're going to need at least 3 of those keys to put them back together in order to generate your root key and unseal the cluster. If anyone's familiar with Shamir keys, that's essentially what we're doing here. And that stops you from, if you need to, you can kind of, I don't want to say rug pull, but you can kind of pull the plug on your entire cluster, right? Make sure that it goes back into a sealed state. And now you have this distributed trust, which to get it back running again, you need multiple people to come together to do that. And there are some ways of automating that as well, but that starts to probably get a little bit deeper than what we need to talk about for today. So how does, once we've gotten that root key back, we've connected to our storage with a config file that tells us where to actually access it. What do we end up with here? And how do commands run through the system? What are all these different components? I think a good way of going through them is with an example. So, and 1 second here, sorry. So a good example is, let's say we're operating with AWS and we have a Lambda function which needs to access a secret. Well, before it can actually do that, it needs to come in through the API. It'll make a request for, I want to access secrets. So it needs to create a new lease for itself. So to make a request to the core will make sure to route that to an Auth method, where maybe we'll authenticate against AWS and an IAM role. And from that, Vault will say, yep, we reach out to AWS, figure out who you are. We confirm you are the Lambda function that you say you are, and we'll give you a lease. And that'll go into our token store in the upper left here. And from that, then we have a lease. We're going to have policies associated with it for what we can actually access. And now that Lambda function can go about, okay, I want to connect to a secret engine. Maybe let's stick with AWS. We need an IAM role. And from that, we can then reach back in again. We have our lease. We've already authenticated who we are. And now against that policy, Vault will check to make sure that that Lambda function can actually ask for that AWS credential. We'll go into the secret engine. Yep, we're allowed. We get it back and we return those credentials back. And part of those might be that they're dynamic, right? They're going to be generated just in time for us. You can make those very complex because of that. We'll set a time to live on it, which will then be handled by this expiration manager, because that'll handle going back to clean up at a certain point and get rid of those credentials from the system. And we'll return that back to that Lambda function. It can go do whatever it wants. And that really brings us then to the last functionality here of The core throughout all of this would have been sending any transaction to the audit broker, which then branches that out and shoots it out to the different audit devices we have associated. And then the one final thing we have here is our Rollback Manager. So the Rollback Manager will handle if a secret for some reason gets half written to the system, there's some sort of error, it occasionally goes through and makes sure it cleans those up so that they're not just sitting within the system forever. So this is the overall architecture. Like I said, it's a bit more of an advanced topic. I think it's interesting to see how it's all laid out, but it's not necessarily something you need to run it day to day. So that brings us into, let's talk about more the, I get how it works, I get how it's architected, but let's then zoom out just one level and look at, okay, I have my Vault server, but how do I make sure it stays up, right? If I'm gonna start leveraging something like Vault, I need to make sure that it's not really gonna go down, because that would obviously cause a lot of issues if it's your central authorization and authentication method. So we've really put a lot of thought into this. In this case, load balancer sits at the front, right? Make sure to balance across multiple instances. And in this specific example, because there are a couple different ways to architect, which I'll get into, we have 3 versions of the Vault server. So we have our primary, which is going to handle all of our requests. And we're going to have 2 standbys, right? So 3 instances in total. Any requests go to the standby, they're really going to just proxy traffic over to the primary. And this ensures that if we were to lose the primary, which might be sitting in AWS availability zone, US East 1A, if something were to happen to that AZ, we have 2 other availability zones up, and one of our standbys will be promoted to the primary. And we use a RAF protocol for this. It's very advanced. It's something that if you want to look into, there's a great site called I believe it's the Secret Lives of Data that goes through how that process works in depth. It's a good resource if you want to check it out. I don't know if one of the TAs knows it, actually, I guess they could drop it into the chat. But as you can see, that's only one part of this, right? We have the Vault servers, but below you'll see this Consul cluster, which some of you may be familiar with Consul, but in this case, we're using it as a storage backend. So if we go one slide back, right, we had this storage backend where we put all of the information that Vault actually runs on and the secrets it has, the auth methods, that sort of thing. And this Consul cluster, also highly available, right? 5 instances of it running across 3 AZs. It has a similar RAF protocol of electing primaries, that sort of thing. This is one way of going about it. If you take a look at these slides later and you click into high availability, then you'll actually be able to see a couple of the different backends. This is one of the more popular ones that we have, along with the Vault integrated storage. They each have some different advantages. It's something you probably want to talk more one-on-one with an account team for, but we do see more people just doing an integrated Vault backend, where essentially it's 5 instances of Vault laid out just like this Consul cluster is, but not having to deal with 2 systems then. But it's not necessarily a fit for everyone. So we ensure then with this setup that Vault is highly available within a region, but nobody's business runs just in one region, right? We end up running across multiple regions. So that's where we then get into leveraging replication. And in this case, take a look at this center Vault cluster up here. What we're looking at is essentially just a zoom out of the screen before. As you can see a pattern here of us slowly building upon what we're going through. So we are zooming out here. This is a highly available cluster within that region across multi-AZ. But you probably also have applications which need to access secrets on maybe the East Coast and the West Coast. So in this case, we use what we call performance replication to another fully, redundant cluster, just like we saw in the previous slide, but running in separate regions. And now what we're going to replicate with that is we're going to replicate our secrets engines, our auth methods, really how we've configured the system so that same applications can authenticate the same ways. They can access the same secrets without us having to, reset up the entire same system in a different place. And these clusters are active, so they will serve out secrets to whatever might be accessing them locally. We keep a low latency that way. It's really performant. If there are any writes, those will go back to the main cluster, but any reads can always come off of these edge clusters. But the one thing that we're not replicating is going to be leases and tokens that are active. So that's where our DR replication comes in. So if you wanted an instance where, hey, I want my cluster to be able to fail over and have all of my applications still running, they don't have to come back, get new leases, right? Essentially re-authenticate. That's where this DR replication comes into play. And this is more of a standby cluster. So the big disadvantage of this then is that it's not actively serving requests like we are with the performance replication. So they fit different needs, right? It's, do you want to replicate your leases and tokens so that you can have immediate failover and not get those? Or do you need really low latency in another location? And in some cases, people are actually able to operate just with the performance replication, but it depends a little bit on how your applications work. So these two can go hand in hand, just like you see in this picture. And it becomes a really powerful way of making this a much more global system where you're not having to, micromanage a Vault cluster in every single region. So that brings us to the end of chapter 1 now. And we do have just a small quiz. We'll have a small quiz at the end of each section. Just put your answer into the chat. I think this is the most open-ended of all of them. So give me some ideas, right? Like, what is HashiCorp Vault at a high level? And I'll give you guys maybe like 15, 20 seconds just to put some answers in there. Secrets management system, obviously, that's good. A way of life, I like that. I live and breathe it. I have a Vault poster hanging over my bed. Secret Vault, yeah, okay. So a couple good answers in there. Yeah, just-in-time provisioning, that's a great one. And you'll see a lot of those answers here. So API-driven, secrets management system. I think I saw zero trust in there, right? Untrusted networks. We saw short-lived secrets thrown in there. So I think you guys got most of those. So that was Vault as a whole. I think we get to see a lot of architecture in this first chapter, and I think it's what makes it one of the longest chapters as well. So from that, then we'll jump into chapter 2, which starts to get a bit more nitty-gritty in terms of how we actually interact with Vault. So jumping into this then, there are 3 ways to go about actually using Vault. There's the CLI, there's the UI, and there's the API. Now, I will reiterate, first and foremost, Vault is an incredible platform for machine authentication and authorization, which means that really the API is going to be key, right? It's made for our applications to get secrets quickly, dynamically, get them instantly, stop any sort of like ticket-driven methods that are a little bit slower. There is the UI, which has a ton of functionality in it, but we're making something for machines, which is why the API is the be-all and end-all of this system and why everything else is going to be made around it. And that becomes clear with the CLI, because really the CLI is just a thin wrapper around the API, which maps pretty much one-to-one. It's a Go application, really easy to install. Honestly, you could get it going, running locally in the next 5 minutes if you wanted to on your laptop. It's incredibly simple. I couldn't believe the first time I ever went to install it. I thought it was going to be a slog, and it just kind of gets up and running. At least, outside of when you run it in production, you have to do a little bit more to get it going with things like load balancers. But if you just want to get it running, it's incredibly simple. So installing that, right? You can go to a tutorial that's linked in the slides. I think at some point, Mike dropped that in there if you want to look through some of the slides. Download the zip file, unpack the binary, right? Place it in your path, and you're pretty much up and running to the point where you can start running a couple of basic commands. So Vault will give you a couple common ones, right? Here's some easy ones. So checking the version, find out what you're actually running. Our product teams are great. They're dropping new versions pretty often, at least, you know, I think there's a minor revision like once a month. So pretty quick team there. And, you know, you have read, so we can read secrets from Vault. We have write, so we can write secrets to Vault. Pretty easy commands. And then, of course, if you're ever looking for more help with commands, just like most command line operations you've ever seen, you can use a -h, -help, -help. So those flags will let you get help with any CLI commands you might be having trouble with. So either, you know, Vault -8 if you want something, -h if you want something really general, but if you want more information on like a Vault read, if you're unfamiliar with command line operations, right? Do Vault read -h. So, and a lot of this is really well documented on our websites. I love a lot of our public facing documentation. I think it's incredibly simple, and, you know, none of it's ever behind a paywall. It's really easy to find on our website. So highly encourage you. Most of the ways I usually find stuff is like Google, you know, Vault and whatever I'm looking for. And then we have a couple different server modes. Well, two different server modes. We have dev mode that is intended really just for development. I'm talking running locally and just trying out features. And prod mode, which is really used then for your QA and production, right? Anything that you're actually protecting in your production environment. You know, please just never put a production secret into the dev mode. Never ever do it. I hear that every time you do that, a HashiCorp support engineer goes gray. So try and stay away from that. Just never do it. It's not secure. Everything's in memory, right? The cluster's automatically unsealed. It's just not a good idea, right? You're going to lose that as soon as you turn it off. Never ever use dev mode for production secrets. And I will reiterate that probably several times through this because we just want to avoid it, right? If you're going to start using it in production, please run in the production mode, even though it's a little bit more work to get going. So for the Vault UI, right, you sign in. That can be through a variety of authentication methods, as we've talked about. So humans can use, you know, your single sign-on, your LDAP, your basic user password, GitHub. There's a ton of different options out there for how you can access it. Whenever you create a new server, you're only going to have the token authentication method available. So you're going to get a token. This actually, I want to get out ahead of this for when you get to the workshop portion as well. At some point, you're going to be given that token, and the instruct platform is going to tell you, save this outside of the window. Please do that, because you'll get to a point where if you don't, then you are going to have to start from the beginning because you're not going to have it. So with the challenge, right, you use the token auth method, specify root as the token, but there are going to be some where you need to make sure you write that down. If ever an instruct tells you to save something outside of the main window, please do it so you don't have to start over. So signing to the UI, I mean, here's another picture of it. It's very simple. From the method, you actually select what you're looking for. So whether that's, you know, you're signing in with a basic root token, or you're using your user password, a lot of the methods we talked about, you jump in there, very straightforward. And once you're in, this is what you're going to see. You're also going to see a welcome to Vault tour on the top. If you want, go ahead, go through that. I think it's nice to see sometimes. Me personally, I'm a big fan of take 5 minutes, click around, just see what's in there, right? I think that's one of the best ways to explore the platform. Not going to break anything. It's, you know, in a complete segmented demo environment. So go crazy, click on everything. I think it's one of the best ways to get familiar with the platform. But once you're done with that welcome to Vault, of course, hit the X in the corner and get rid of it. So that brings us to the API. And of course, everything in the UI is backed by that API as well. It is our be all and end all, and everything comes off of that API. Some simple commands, right? Here's one, for example, do a curl to get the system health and format into that into a JSON output. And this is what it's going to look like. You'll see a couple different things. So have we initialized, right? That means like, have I actually just started the binary? It might still be in a sealed state. So we could have true or false. If you're running this in the lab, you've probably unsealed it already. So it might actually have you run it before and after. Whether it's a standby, it's the primary, are we doing like a performance standby? Do you have replication enabled, right? We have that performance mode that we talked about before for having another cluster that actually serves out secrets, or we have the DR mode for the one that replicates your leases and tokens so that you can fail over and keep running without having to get new ones. Server time, version, we got the cluster name, cluster ID, so pretty simple stuff. But you can see our commands are pretty easy. Same thing, if you ever need to figure out what any of them do, head over to our public facing documentation. They do a really good job putting it together. So that sys health endpoint doesn't actually, it's one of two commands, I believe, that doesn't require any authentication. It's checking the health, and the other one is the command to unseal the cluster. So not too much that's available prior to unsealing, which makes it very, very safe. And then authentication, right? If you're doing that, is done with a Vault token, and that's provided with just a pretty simple header. So, like I said, the other chapters are a lot shorter than chapter 1. So let's get some answers in chat for the first one, maybe, of how can you interact with Vault, right? There are 3 methods. Okay, quick off the jump there by a lot of you. Perfect. CLI, UI, API, love that. What options can you use to get help for Vault commands? Really, if you remember just one, you're good. You don't need all of them. Yep, -H, perfect. -help, -help, got it. And then what are the 2 Vault server modes? Dev prod, and we never, ever, ever put production secrets in dev. So perfect. Those are all the answers we had there. And with that, you know, I think we've gone about an hour now. So maybe Marissa, do you think we could just take a couple minutes here, have a small break for everyone?
Yeah, why don't we, do you want to do like a 10-minute break now and they'll come back around 1:15?
Yeah, that sounds
Okay.
perfect.
Okay, awesome. Sounds good. Okay, so everybody, so just plan to be back at 1:15 and then we'll go into the next 2 chapters.
Okay, 1:15. Welcome back, everybody. Looking through here, chat might give me a heart attack at this rate. So if I drop down, Mike, just jump in, start going through the slides. Don't worry about it. So chapter 3 here, right? We got 4 more chapters, and then we'll jump into actual workshops. These chapters should go a little bit quicker. Like I said, you saw chapter 2, it started going faster. Same thing, any questions, jump in, ask. The TAs are more than happy to answer anything. So, and I think we'll probably go through these 4 all the way and then take a short break after that before jumping into the lab. So, running a production Vault server, right? We're not using dev, we're running in production with a real server, and that involves a couple steps. So, one of the first things is going to be a config file. On the next slide, we'll actually talk about the main components of that config file. Once you've done that, you'll start up the server, and you'll do this with all new Vault servers, is it has to be initialized. And when you initialize, you are going to get the unseal keys. So those are what we talked about before. They are sharded keys. You're going to get by default 5 of them that come together to make your root key, which helps you unencrypt your storage encryption key to actually access the storage. So you'll get those different unseal keys that are sharded. You'll want to distribute them to 5 different people. There's a couple different ways of going about that, actually, especially if you don't want them in plain text ever. There's some ways around it. And then you will also get your initial root token so that you can actually authenticate for the first time before you set up all your different authentication methods. And then finally, of course, once you've got that set up, you'll take your unseal keys, you'll unseal the vault for the first time, and you'll start to get going. So next slide here is where we start to get into what's actually in that config file. This is specified in either HashiCorp configuration language, which is HCL, or JSON. If you haven't done too much Terraform, maybe you're not familiar with HCL yet, but we find that it's pretty readable. I actually love it once, I think a lot of people, their initial reaction is like, well, why did we need another? We got YAML, we got JSON. Still great for machines. I think one of the most readable out there. It's really fantastic. So some of the common configuration settings, we have the listener, where we're actually going to be, configuring how we see our API requests, that sort of thing. What does our storage backend look like? So where is it? How do I access it? There are a ton of different backends, like I talked about before. You can do the Vault integrated one, you can do Consul, you can do like etcd, and there's a few others. You have seal, so configuring any configuration settings about that sealing process. For example, you can start to get into things or use another Vault cluster for auto unseal, so you might have a couple settings around that. Your log level, which of course, how verbose do you want your logging to be? Most verbose is trace, and I think like least might be warning or something like that. I think there's about 5 different levels. You have the UI, so whether you want it enabled, disabled, that sort of thing. We have the API address, which is then there for how do we let the other Vault servers know where to do client redirection. And then we have the last one here, which is cluster address, which is how do we let our other Vault servers know where we're doing request forwarding. So those are a lot of the common settings. You'll get that set up. You'll run your Vault init, which we'll look at that, get you your unseal keys, that sort of thing. So once we've done that, right, you'll start it up. You'll use the Vault server program to get it going. We are not using the -dev option because in this case, we're going to be running an actual production server. And from that, then we have a couple steps for initialization. Since it's going to be a production one, a Vault cluster is going to run multiple servers. Like we showed before, the best practice is 3 or 5 servers, depending on what storage backend you're using and how you're setting it up. And those will run across 3 different availability zones. And each Vault cluster must be initialized once. We went over that before of you need to do that in order to get your unseal keys. you do that with the vault operator init command. And of course, if you ever can't remember it, you do a vault-h, and I'm sure you'll figure it out pretty quickly. And then the number of key shares and key threshold, right? So these keys it's talking about are our unseal keys, right? Our sharded keys that we have to put together in order to make our root key. The key shares is going to be how many of those do you have? Default is 5. Key threshold is how many do you need to be able to access the root key? That's defaulted to 3. And the command returns unseal keys and the initial root token for the cluster once you do that initialization. And so once you want to go unseal that vault cluster, right? This is the next step after we initialize. Each vault server has to be unsealed each time it's started. So if you've got it started unsealed and at some point it could be, I don't know, because you need to shut it down for maintenance for some reason, or maybe you need to, you have some huge security breach, right? You want to pull the plug on Vault to make sure that you're maintaining control of it, stopping the blast radius on everything. You might seal it again. So every time you reboot it, you're going to have to unseal it once more, which means you'll have to bring together all your different people who have the different key shards and get at least with the default, a majority of them 3 together. So you can't use the server at all until it's unsealed, except for checking the status, as we saw, I think, with one of the commands in chapter 2. And you do this using the vault operator unseal command. So you'll do vault operator unseal. It'll ask you for one of the keys, you'll provide it, and you'll do that 3 times with the default settings. And so once you've actually got that running, you can use the vault status command in the CLI to actually find out the status of the server. So it'll tell you, is it initialized, is it sealed, unsealed, just some very basic settings. And then it'll also tell you things like, right, the key shares and the key threshold, which we defined before, the HA mode, right, clustering is enabled. You saw a very similar output when we looked at how would you look at that with the API to check the status of the system. So you should be familiar with that. So chapter 3 review then. Hopefully everyone is paying attention. So what is used to configure a prod mode vault server? Perfect. 2 good answers there, right? Some sort of config file. It can be in HCL, it can be in JSON, but you're going to need that. So vault command needs to be run once against a new vault cluster. And right, we got to make sure that we actually take a look at what's in that config file with that. So perfect. I think someone put the full one in there. Vault operator init, that's perfect. And then finally, what vault command has to be run each time vault server is started? Perfect. Vault operator unseal, right? If we haven't started it, then we won't be able to open it. And honestly, vault status is a good one too. We want to make sure we're actually checking we did it correctly. So those are our answers for chapter 3, and we will roll right into chapter 4. Which is our vault secrets engines, right? That was one of our 3 points of the triangle. We had our clients at the top, and then bottom left, we had our vault authentication methods, which we'll also have a chapter on. Bottom right, we had our vault secrets engines. This is a slightly different snapshot that you saw before. Screenshot was probably taken at a different time. But you'll see very similar options, right? We have all our generic ones we've talked about, basic key values, which we'll mostly cover during this chapter, but always other ones to mention, right? So here's a good list of them. So we have PKI actually handling your certificates for different applications. This can become really powerful. I've heard crazy processes out there, which is no one's fault, right? It's just difficult to manage. Nobody really wants to deal with it. So trying to get certificates to prove your application who it says it is, a lot of the times people give long-lasting certificates, which will last, years in some cases. once you start leveraging it with Vault, and you're going to see it's fully automated, you'll probably start setting those much shorter timeframes. You know, you can set them to a week, set them less if you want, as long as you've got the automated process in the background, or even the application hard coding it, or not hard coding in, but putting the logic in there to reach out and get a new certificate. You could have SSH keys. You could have, you know, developers authenticating with GitHub to then get a SSH key to access a certain instance. We have the time-based one-time passwords. So if you're using multi-factor authentication, Vault can actually generate those codes for you. We have our databases, tons of databases supported. This is usually one of the biggest reasons why people start using Vault, is because they want dynamic database credentials. And it's because it's just so powerful to be able to, every time you need access, right? You can go down to 1 second of a time to live on those passwords if you want, if you really, you know, you authenticate that quickly and then you throw it away and delete it. You can have those be, since they're dynamic, they can be 100 characters long if you want. They can be extremely complex. They're individual every time. So we know exactly if there was a breach, you know, you could trace it back to where it came from. Really powerful. This is where we see so many people start to leverage Vault. And then on the cloud side, right, AWS, I think we talked about how you can use AWS to generate dynamic access keys. We actually have a whole chapter on that later, so I'm not going to dive into that too much. Active Directory, same sort of thing. Do you want, you can have service accounts to get checked in and out, or you can even have dynamically generated username passwords for you to access certain resources. And then finally, the last big one here, which is transit, which is your encryption as a service sort of approach. So we talked about that before, right? Don't necessarily want to have to deal with trusting every single underlying platform or database of how's it doing its encryption, right? You can have it handled at the app layer instead. Send data over to Vault, it'll encrypt it, send it back. You can hit another API to decrypt that data. Incredibly powerful. So those are all the different secrets engines. Like I said, we'll be focusing a little bit more just on key value here, because that's what's going to be done in the actual workshop, just to get you used to, you know, how do I enable and start using a secrets engine? Because once you understand how to use one, you're going to quickly understand how the rest of them work, because it's a very similar process. So most of the Vault secrets engines need to be just enabled. This is done with a pretty simple command. So you'll say Vault secrets enable. You'll put the name of what you're actually trying to enable. And each secrets engine is going to have a default path. So the reason that, you know, there is a default path, you can use it, but what you're going to quickly run into is that you're going to have multiple lines of businesses or teams who each want their own, maybe KV secrets engine, or in this case, we have AWS secrets engine used. So we want to enable that. And then we can explicitly call out a path for like AWS East. And you could also have then your AWS West, right? And this allows you to then have multiple instances of a single secrets engine, as long as they're along different paths. And you can see that below then, right? Your custom paths specified in CLA commands and API calls. Same thing as above, really. So diving more into that KV secrets engine then, there are actually two versions of it. The KVV1 had no versioning. So as soon as you overwrote a secret, that was just the new one that you had, you couldn't go back and access old ones. We understand in some cases, some people actually still prefer that, but there is a V2 now. So you can have versioning if you want, and we'll actually enable that version of it in the workshop, the KVV2. And it's automatically enabled for dev mode servers, which is really nice, because if you just want to spin one up locally, play around with something, it's really quick to get going. But when you launch a prod one, there's nothing there. You'll have to go and actually enable it yourself. But that's a really big difference, right, between KVV1 and KVV2, is just that versioning aspect of it. And so you can see a couple of the example commands here. If we want to mount that instance we had talked about before, right? Vault secrets enable, just like 2 slides ago. And now we actually declare which secrets engine we want. We could also define our path here, like we said before. In this case, we want version 2 of the KV secrets engine. So we put that after that. And then here are a couple generic commands of what you can actually do. So most of them are pretty self-explanatory, but we'll go through them here. So KV list all the secrets that are in that path. If you want to write new secrets, you'll put a put. And if you want to get secrets out of it, read a secret, you'll use get. And then of course, delete if you want to delete secrets at that path. And you can, of course, then, we'll get into policies later, but people can be restricted over which commands they actually have access to. Maybe you have a certain machine that really should only be reading access, so reading secrets. So you limit that access and only allow it to have the ability to use get. And then, yeah, other Vault KV subcommands operate on versions of KV v2 secrets. So that's going to do it for our chapter 4 review. Let's go through a couple questions. So what option is added to the Vault secrets enable command to enable multiple instances? Yeah. Perfect. Path, right? That way we can have multiple of the same secrets engine, but name different things. So what's the difference between the 2 versions of the KV secrets engine? Bonus points if you say which is which. Perfect. Versioning KV2. And can an old version of a KV v2 secret be retrieved? Yeah, I think you can do some inferring there if you had to. So those are our answers. Very straightforward, and that'll bring us into chapter 5. So chapter 5 here. Sorry, I'm just gonna make a note. So chapter 5, Vault authentication methods, right? The other big corner of our triangle. And I don't think we've shown you a screenshot of this yet, so this will be good to see. And of course, this is changing all the time. Like I said, the dev teams are always real busy. So a couple generic ones, right? We have this idea of an app role, and actually we'll jump into the next slide to be able to look at these more. Yeah, instead of starting with app role, let's look at the left side and start with humans, right? Human authentication versus machine authentication. So these ones you're going to be familiar with. I think we've gone over these a couple times already today, but user pass, GitHub, LDAP, JSON Web Tokens, Okta, right? Basically single sign-ons, any sort of LDAP system you have out there is going to be, or like OIDC method you have out there is going to be supported. And as always, you know, there's the ability for you to create your own custom one if you want. The same thing we had said about the secrets engines, which is great. There's a lot of community behind some of those, especially popular methods that we might not be directly supporting yet, as well as just creating your own if you have something really unique because of the pluggable nature. It's very extensible. And then we have methods for applications, which is really what the big thing is here, is that trying to, as we talked about, the big problem with the shift that we've gone through in the past couple of years is that we can't keep track of all our IP addresses. So of course, how are we authenticating all these different things? Well, AWS IAM roles are perfect. App roles are really great as well. They're a little bit more custom, where you're pretty much just using a role and a role ID. You can apply it to almost anything, especially some on-premise environments that maybe don't track identity the same way the cloud platforms do. There are other clouds here, as well as different platforms like Kubernetes, right? Where we can start authenticating through there using JWT tokens as well. So pretty powerful. A lot of people like leveraging those. And, you know, if you have something that runs across a lot of these as well, it's worth noting that they can come together to really form just one entity. You're not locked into, you know, you have to use this one role. No, something could obviously authenticate in multiple ways. So enabling the authentication methods. I think this is going to look very similar to the way we just looked at how do we enable the secrets engine. So instead of the secrets enable, it's Vault auth enable. Pretty simple. And you'll follow that up with exactly what you want to enable, as well as similar thinking if you want a path because you want multiple instances of it. that's no problem. Put a path, put the secrets engine you want, and you're kind of off to the races there. So what does that look like? Well, I think we saw this before, but you're able to actually choose your method from a drop-down list, or if you're using the API, right, you specify, and you'll be able to sign in right away. And of course, machines will always be going through something like the API or CLI. So quick chapter there, because really a lot of it looks exactly the same as secrets, except we're just defining how we're authenticating instead. So a couple questions, right? What types of entities can Vault authenticate? There's 2 of them. Yep, users and apps, perfect. Users, machines, also a good way of putting it. Remember, machines, systems, apps gets very vague, and it works across all of them, whether that's a pipeline or it's a traditional VM or it's Lambda, whatever it might be, or the application code itself will accommodate it. What system manages credentials for the user path auth method? Perfect, yeah. Got one answer in there. So it's going to be Vault, right? It's just a basic username password that's managed by Vault, as opposed to using maybe one of your other systems. And then finally, can a user that is not assigned any policies other than the default policy access any secrets? Perfect, no, right? You got to make sure that you're giving that access out. So great answers there, as always, getting them all right. And that brings us into chapter 6. And this will be the last one before we jump into some of the workshops. Before we do that, maybe we'll take 5 minutes once we get there, but let's get through this chapter. So Vault policies, right? That was the part connecting our auth methods to our secrets. We have things authenticated, they have tokens, and then, or they have leases. What are they actually allowed to access? And, I think we just answered this actually on the last quiz question from the last section, but it's least privilege, right? So we deny access by default, and then you must explicitly grant users or applications access to those specific paths. We'll take a look at what one of those looks like. And we don't just set, what paths you have access to, but rather what you can do in those paths as well, which I think I mentioned before of, if you want to make sure somebody can only read secrets, you can secure them to that. Or if you want to make sure they can only write secrets, you have a lot of flexibility. And then, of course, all policies are written in HashiCorp configuration language, keeping things very consistent and very easy to use. So let's look at what one of these looks like. In this case, what we have is there's a couple components, right? We're going to define, this is the path we want access to. We'll look at the auth method. We have a path given here, right? This is an auth method. We're looking for tokens. And so the capabilities that we're going to give it here are going to be able to read. So this token is going to be able to, this token is going to actually be able to look up its own properties. That doesn't mean it can change them, right? It just has read access, but it'll be able to check those. And so the path of policy maps to a Vault API path, right? We just showed that on the last one. We were looking for a token. Most common capabilities, and these are going to map directly to a lot of the HTTP verbs. You want to do CRUD operations, right? Create, read, update, delete, list. Very simple. Those are most of the things that you're going to want to do. But there are 2 other capabilities. One of those is going to allow access to paths that are root protected. And then deny is going to give you things like denying access to a path. And that's going to take precedence over other capabilities. So instances you might use that, right? Maybe you give access to actually, great example on the next slide, right? You give access to everything in this path with the glob character, being able to look at anything within that. So you can have as many folders after that. You have rights on that. But let's say there's one specific section. You could then give somebody a deny capability on that one path you don't want them to look at within that. And that will override the ability to read all given by the glob character. So this is a good slide. I kind of use it for something else, but this slide's great because it shows the structure that a lot of people start to lay out those paths. And that's going to be something that you'll keep in mind as you start to approach Vault and you initially set it up in a production environment. If you haven't, really take a look at what makes sense for us, right? Do we want to separate by line of businesses and then departments? And then you could even go deeper, right? You could do teams within that. There's plenty of ways to do it. All of them are probably right in their own ways. But it's important just to see what makes sense for your own business. This is certainly not the be all and end all of how to set it up. And so Vault policies can be added to a Vault server using Vault CLI, UI, API. So in the UI, right, there's a section for policies. You'll see it in the workshop where you could go in and you could directly just type these in. Or what's more likely is you're probably going to have these policy HCL files around because you're going to programmatically create other secrets, I would guess, or other auth methods, and you're going to want to give access to them. So you might be generating these HCL files. You might have a template that you can apply to new ones. And so to do that, you'll write to what the policy is called, as well as where that is actually stored, and that'll dictate who and what has access. So that's chapter 6. That's our last one of the Vault Basics section, which will lead us into our lab. But before we do that, let's go through our chapter 6 review. So does Vault grant access to secrets by default? No. Glad to see the quick one on that. Yes, no, it does not. You have to grant access for people or machines, and you have to explicitly do that. What are the policy capabilities that correspond to HTTP verbs? There's going to be a couple of them. There are 5 of them. Perfect. Yep. That's the CRUD operations and list. So create, read, update, delete, list. And then finally, what CLI commands can be used to add a policy to Vault? Not sure if I explicitly read that out enough, but yes, perfect. Vault policy right. So those are the answers to our chapter 6 review. I think maybe before we jump back into overviewing the lab and actually getting into the workshops, may we go into just slightly shorter break than last time. What do you think, Marissa?
Yeah, I think that's good. Why don't we come back at 1:50?
Perfect.
Okay, awesome. So we'll be back at 1:50, everybody, and then we'll go into some of the labs. So talk to you soon.
explain. There we go. We will explain how the lab's going to work. It's a great system. I think you're going to like it if you haven't used it before. If you have used Instruct, help out anyone who's having trouble. So doing labs with the Instruct platform, like I said at the beginning, the best thing you can do, I know everybody's got their browsers of choice, but I have seen Chrome generally solves most of the issues that people run into, even if you have to just use it for this half hour or so here. As well as jumping off of any VPNs, or if for some reason you're operating out of a VM, jump out of that. I think you'll solve most of the issues you might run into. So the Vault Basics Labs covers everything we just went through in chapters 2 through 6. There are going to be 2 other labs. They're on more AWS focused topics, which we'll get into once we've run through the basics. We'll come back, overview how those components actually work, and then we'll jump into the labs for them. Somebody will in your breakout rooms, they'll give you the link to access the track so that you're able to pull it up. If it's your first time using Instruct, you might have to do 1 or 2 extra steps, but it's generally pretty straightforward, and you'll accept a ULL, they'll populate for you, and you'll be able to jump into them. Just make sure that the first one of the 3 that you see, you do the Vault Basics one. And I'm sure that'll be reiterated by the TAs for you. So the first challenge, right, is going to be just kind of getting up comfortable with the CLI. As we talked about, it'll be a lot of the same commands. So you'll start the Vault Basics track like I talked about, hit the start button, it'll boot up, you'll get a little bit of information on what the challenge is going to be. Once you actually see that and the challenge is finished loading, you'll press the start button in the bottom right, which will pull up more of your CLI interface. So you'll start following the instructions on the right, it'll have things to copy paste in. And once you've done all of the steps, you'll hit the check button in the bottom right, and you'll be able to keep going to make sure it works. If you, for some reason, are running into issues where the check isn't working, go ahead, just ask the TA that's in the room. Sometimes the issues are a bit weird. You'll be able to work them out. And like I said, if within the Vault track at all, it ever asks you to save something outside of Instruct, please do so that you don't run into an issue where you might have to start from scratch because you don't have something like an access token. So second one, we'll get into how do you actually start running a Vault dev server. All the challenges are going to be very simple or very similar in how they operate compared to what I just talked about on the first one. So we'll skip through that. Next one, challenge 3, you're going to check the health of the Vault server. You're actually going to read your first secret then. Next part of it, you're going to run one now in prod. So this is where you'll actually learn how to go through that initialize phase, right? Which looks at a config file, sets it up with the storage backend. You'll go through the unsealing process and you'll see how that all works with the key sharding. You'll look more into how the different secrets engines works, right? Before this, you have only read secrets, but in this case, you'll actually enable one of the secrets engines and then work with that path. We'll move on to the next challenge, which will be checking out the different authentication methods, right? Not just accessing secrets, but I think it's setting up basic username passwords for 1 or 2 users. And then finally, the last challenge of that is that you will use Vault policies on those users you create in the previous challenge, and then segment their access so that one will be able to access a certain path and the other one won't. So that's everything in terms of the challenges. If you don't remember anything else, please remember Chrome is your friend for this next half hour. Marissa, I think we are good to split into groups.
Awesome. So I just opened up all the rooms. So you should see a message to join them. So if you can go ahead and do that. If for some reason you are having an issue accessing your room, just let me know.
Marissa, which room was I supposed to be in? I lost the invite on my screen for some reason. Or did you not need me in one? I think you do, right?
Yeah, let me, hold on one second.
Okay, perfect. So I think we hopefully all got through most of that. I was seeing the completions coming in, rising quick. If you did have, one or two sections that left, you can always revisit it. I think somebody said in the chat that these should be available for 30 days. Plus, you might actually finish one of the next two activities a little bit early, and then you can jump back to it if you like. So the next two that we're going to talk about, we'll do one, we'll jump back into a lab, and then we'll come do the same thing where we talk about the next one and then jump into a lab. But these final two that we're looking at are going to be both AWS specific. So we're speaking on a secret engine related to AWS and a authentication method that is related to AWS. So these are pretty cool integrations. They're heavily used on the platform. So let me get started here. So yeah, this is just, we did the previous workshop. You can see here, this is what I just mentioned. We'll start with the dynamic secrets first, and then we'll move into the authentication method. Lab environment, you're already familiar with Instruct now. You should be all set up. So we are generating credentials for AWS with Vault. And this is, of course, using the AWS Secrets engine. And using that, we're able to generate access credentials and access keys, secret access keys dynamically and based off of existing IAM policies. So this is pretty powerful stuff. I mean, use cases I think are apparent. I mean, I could take one that's maybe a little bit more HashiCorp related. We sometimes see people who are using Terraform and they have different workspaces, right? And those workspaces need to reach out into AWS. They can generate IAM policies for those with access keys so they can go out and deploy infrastructure to them. You could also have use cases where you have developers that need to access the console for different reasons. And you kind of want to have like a vending machine for them of how to get accounts that they can access. Those won't last forever, which can be a pretty cool thing. I know we use it all the time. So it makes just working with IAM much easier. There's not all this management around using the UI then for getting these accounts out there. It's a lot less error prone. You can turn them around much faster because you can have an internal kind of front facing system and then you can access from there, getting credentials from it, or you could, get them from Vault directly if you want to give users access to that. And just with everything else in Vault, very easy to be automated. So when you're generating these credentials, you can have users authenticate with all the usual authentication methods that we've looked at. So even if you wanted to keep it as easy as developers authenticate with GitHub, and then you give them IAM policies that they have access to, and they're able to get their access keys from that, that's a perfect way of using the system. Because they are dynamic, we can ensure that if there is a breach and somebody gets access to them, they want to start doing something like, I don't know, crypto mining, right, on your AWS instances, there's only so much time they could do it before they lose access with those credentials if they were leaked in some way, because of course we'll go back and we will revoke those once the lease is expired with that revocation manager that we talked about way back in the beginning when we were going through the architecture. And so we can do 3 different types of credentials. Most people are just going to do IAM users. The other 2, right, are used a lot of the time for external users, federation tokens especially. So it just depends on what you use, but we see most people just leaning on the initial IAM user. And so Vault will create IAM users for each lease. So, a lease being you have, whether that's a machine like something like Terraform who needs a user, or you have an actual, developer that needs a IAM profile. They each have their own leases. They are going to have policies that dictate which ones they can access. And then, of course, they'll get a user that meets that profile that has been set out by some sort of admin ahead of time for what their access will be. They'll get those, return them to the caller. They can use them however they like. When you use the others, assumed role and federation tokens, it's very similar, but in this case, you also get a session token back to the caller for assumed role, not just the access keys. And the same thing when we're talking about federation tokens. So it's a little bit different. The demo that you guys are going to be doing, or workshop that you're going to be doing, is going to use the IAM user Vault Secrets engine. So you'll get hands-on with that. But if you do want to learn about the 2 others, we've got links here if you want to pull up the slides and click on those, and you can take a deeper dive. But with that, we'll jump into the dynamic secrets, and we'll head back into breakout rooms where you'll enable these, you'll configure them, and you'll generate and revoke credentials. It's a really cool demo. One of the best parts about the platform, I think. So Marissa, we should be all good to go.
Great. I just opened the rooms, so feel free to proceed to your rooms. Thank you, everyone.
So we're entering the last part of our lecture for the day. This is, of course, going to be on the other AWS Auth method the other AWS piece, which we had mentioned, which is, of course, the Auth method in this case. And this is then the flip side of the coin, right? How can we start to use what we already have for identity in AWS to provide authentication into Vault so that you're able to then get a lease to access secrets, that sort of thing. So no need to go back through here, what is an Auth method? I think we've really driven that home at this point. But it's a great mechanism for pretty much anything in AWS with an IAM principal or EC2 instances to get access into Vault so that they can start getting secrets through either the KV engine or whatever it may be. And of course, this is all done without any passwords. We're using AWS as kind of a trusted third party. And from that, we have 2 different methods of going about this. And we'll kind of contrast the 2 right after we go through them. The first one that we'll talk about here is going to be the IAM method. So in this case, what happens is that the resource in question will create a call to the STS API. It's a special request for authentication, right? It gets signed by AWS. And those credentials then are whether they come from a Lambda function or an EC2 instance, it can really be anything, are used to authenticate into Vault. And whether that's the bottom here, even the Iam Auth method authenticates AWS Iam principles, whether those are from roles assumed from other accounts, Lambdas, EC2 instances. You can see it's very broad is kind of the point we're trying to get across here, and allows you to tackle anything. So I think I had just mentioned, right, you make this API request. At that point, it's validated and signed by AWS, and Vault is notified, at which point we can verify where that actually came from. And by doing this, no access keys, secret access keys are ever transmitted in this case, which keeps it as a very secure way of doing things. And that signature algorithm also expires pretty quickly after just 15 minutes. So this is a nice protection against replay attacks as well. And using these methods just further drives home this core concept of Vault, right? Of we're not relying on those IP addresses anymore, but rather we're looking at the individual identity, right? If we have 50 web servers, they all end up as the same IAM identity. We're not managing 50 IP addresses in that case. So then the second method of this is the EC2 method. This one is a little bit older. It only authenticates EC2 instances. But in this case, we're using AWS as a trusted third party. I find the easiest way actually to explain this one is just to jump to the diagram. So what we have here is that it'll be initiated by the EC2 instance, and it's going to reach out to the EC2 metadata service to get an identity document, where AWS is then going to provide the PKCS7 signature with that. And from there, we'll make our request into Vault, who will then want to go and verify that against the public EC2 API, at which point, if it's successful, Vault's going to return the initial Vault token to the EC2 instances, and the token is going to be assigned its various policies so that it can access the secrets it needs. And of course, then we get into further communication outside of this document of just requesting secrets. And of course, these same steps are displayed here, but it's what we just went through. The big takeaway that you want to get from this, right, is that it's very secure. There are multiple ways of doing it. I will say that IAM is going to be the recommended approach, but I mean, obviously you can see EC2 or pretty much everything else. You get a lot more flexibility when it comes to using the IAM role. So what we're going to do is jump into then actually doing this yourself. Same thing. It's the last instruct workshop that you haven't accessed yet. So that's the AWS Auth method for Vault. It's the same URL you used before, so you should already have it open, and you'll go through a couple steps. You'll enable the auth method itself. We'll configure that, and then you will log in and log out using those methods. So we'll jump right into that. I think, Marissa, we are all good to go.
Awesome. All right, the rooms are open, everybody. I have about a 15-minute timer on there. Okay, everybody, welcome back. So we are gonna leave some time for Q&A here at the end. I did want to let you guys know, I'm gonna put a survey in the chat right now. If you don't mind filling that out, if you do, we're gonna give out some different like HashiCorp swag for you guys, to people who fill that out, and then I'll also send that in our follow-up email. I saw a question, will the session be recorded? Yes, I'm going to send that out in a follow-up email. But yeah, if anybody has questions for David, or like just questions in general for our TAs, you can feel free to speak up now.
I will say, while we're waiting to see if anybody posts a question or speaks up, we do have, I know we had a couple questions around, will the slides be available, things like that. So I'm just going to post them once again in the chat here, and you'll be able to access them even going forward. I know the lab will be available for 30 days, and then those slides will be there for, I guess, as long as Mike wants.
Yeah, and I did see a question there in the chat, David. I don't know if you saw that.
Yes, thank you. So the question was, the session covered using the AWS Secrets Engine. Curious how this compares to the Managed Vault offering that was recently announced. Any workflow differences? So most of the differences when you start using the HCP offerings come with just kind of how you operate it, right? It's a little bit less on you. Connecting to it is a little bit different. I know there are some slight functionality differences. I'm not sure. I assume that one is available in HCP as well, unless Mike, you know for sure. Oh, sorry. I think the question got updated here. So compared to the AWS, like the AWS Secrets platform,